Okie dokie. So let's go ahead and do some characteristics of functions based on the exponential that you see above you here. Test on Thursday. So I'll do this and I'll do a little bit of transformations, and this will be the only video for the week for you guys. Okay, so you should have a pretty good understanding of the 5 formulas right now, and then we'll go into some other things this week. So here's my base function, f of x equals 2 to the x power. I'm looking for a certain set of characteristics here, and I will star the ones as we get along here on which ones are most important for you to know, just because they change from function to function. The domain of this function is negative infinity to positive infinity. Go ahead and make sure you pause me to see if you can fill these out correctly. You should be able to at this point, but we'll go from there. Range, so hopefully you unpaused me after you got all these right, or you think you did. The range I'm starring because that's super important. So the range of this function is, what is its lowest y value to its highest y value? The lowest y value here is 0 and it goes to infinity. Right? They're both parentheses because this function will never touch 0 on the y-axis. We'll never get to that point. It will get infinitely close to that point, but it will not touch. The y-intercept here, all base exponential functions have a y-intercept of 1. Okay? Non-transformed is what I mean. X-intercept, there is none. Please make sure you understand that there is no x-intercept here. It will never touch the x-axis. The end behavior, okay, so we'll do the easy way first. As x approaches positive infinity, okay, so as x approaches positive infinity, f of x approaches positive infinity. Okay, so as x goes right, where does y go? Y goes up too. Now the other one that's a little more challenging, or can be, as x approaches negative infinity, f of x approaches 0. Okay, so as x is going left forever, where is y going? Well, y is getting closer to 0, but it will never get there. So we say y, or f of x, approaches 0. Okay? The asymptote as a line, please don't tell me 0 because you're not going to see that on the test. It's going to be the line y equals 0 or whatever it is. Increase and decrease, you may not see that, but it's something to just kind of remember, keep in the back of your mind. This function is always increasing. It will never decrease. So because it will never decrease, we just cross that out. Or we could say the function is decreasing never, or it's never decreasing. Increase, however, where does it begin its increase? So I'm using the quotation marks because it actually never begins and never ends, right? It begins its increase at negative infinity because it's way over here. And then it ends its increase at positive infinity. Okay, so that would be the characteristics that I'm looking for. The asymptote line is also super important, and the x-intercept line, or the x-intercept, is very challenging too, because if there is no transformation, there will not be one. All right? Now let's do one of these with the transformation, and we'll see how things go. Let's actually make it a little challenging. Let's do 2 transformations on it. Okay, so let's see what this does. I'm going to come up with one at the top of my head here. Let's go x-axis reflection and a y-axis reflection. Let's do both of them. All right, now let's make it more challenging. Let's add a third. Let's go +1. Booyah. Okay, so this is the function. F of x equals -2 to the negative x power plus 1. Okay, so -2 to the negative x power plus 1. So I've got 3 transformations here. I've got an x and a y reflection, and then I've got a vertical shift up of 1. Let's go with the characteristics. The domain typically will never change here. There will always be negative infinity to positive infinity. Okay. The range, however, has changed significantly. This function will go down forever. So it begins, or the lowest value here is negative infinity. But what does it go to? What's its highest value? Well, it goes to 1, but this is an asymptote. It will never actually hit 1. So we have to put 1 with a parenthesis here. Okay, no brackets. Y-intercept line, well, we can clearly see that it's 0. Now remember, if you can't see this function, like you don't have Desmos or a graph in front of you, you're going to have to solve for when x is 0 here. So I plug in 0 here, and I would get 0. So x-intercept, the x-intercept is also 0, and then I would solve for y by plugging 0 in for y and solve for x. That's a little more challenging, but this is typically what I'll give you. I'll give you a graph. End behavior. Okay, so let's do the left side first. As x approaches negative infinity, f of x approaches negative infinity. So as x goes left, where does y go? Y goes down. That's what that says. The other side, as x approaches positive infinity, f of x approaches what? Well, as x is going to the right forever, y is approaching 1. Okay? It's approaching 1 because here's my asymptote line, and this is at 1. Okay? The asymptote as a line is the line y equals 1. So all of these are linked together. You can see a couple of patterns. And then the increase, well, this function is always increasing forever. It's never going downhill. So my interval of increase is negative infinity to positive infinity. Okay? It will always increase. Even though it looks like it's not gonna, it's still infinitely getting closer to the line y equals 1, so it will eventually, or it will always go forever up and increase. Okay. So let's talk briefly about some transformations. We just did a few of them right here. So vertical up or vertical down. If this was a vertical down, I would have had a negative here. Okay. Shift right or left. Remember, it's going to be a negative sign for a right shift, and it would be a plus sign for a left shift. The other ones we talk about are vertical stretch and shrink. So if this was 2 to the x power and I multiplied a 3 in front, this is a vertical stretch of 3 units. If it was 1/3 times 2 to the x, it'd be a vertical shrink of 1/3. And then horizontally, right, let's say I did this, 1/2 to the x. Horizontal stretch of 2. Okay? And then if it was just a whole number in front of x like this would be a horizontal shrink of 1/2. Because remember the fraction problem, that changed everything for us. Okay? There may be a fever on there, so video 60 fever, which you've done for video 59 for last week. So if you want to go ahead and do the fever for 61, that would be fine. That's the only one I'm going to give you this week. We're going to do a lot of this stuff in class, so hopefully you can have a good handle on it. Test is going to be challenging, okay, for sure. So make sure you know those 5 formulas. Make sure you have a good understanding of the characteristics of a function, a base function. And also make sure that you have a good handle on transformations because there are going to be a few questions on that. All right? Let me know if you need any help. Wednesday for sure and Thursday morning we'll do a help session. Can't do it tomorrow. Okay.